What if we can replace the electronics with fiber-based photonic computing? That means to take a fiber, which is a piece of glass, elongated glass, and somehow to turn it from something that carries photons from point A to point B to something that processes the data when the photons pass through it.
Eyal Cohen, welcome to 20 Milliliters. Thank you so much for being with me today. How are you?
I'm very well, thank you. Thank you for having me.
Thank you for.
It's great to have an audience. And through you, I hope that people will understand many things that still seem like science fiction.
Let's talk about science fiction. Eyal, you're a co-founder and CEO of CogniFiber in the space of photonic computing. What is that?
Photonic computing, in the basic, it's computing with photons instead of electrons. So our whole technology world today is based on electronics, mostly. But until now, we didn't have any issue with it. I mean, it functioned very well. We did amazing things with that until we reached AI. And artificial intelligence is really challenging for any type of hardware because the demand for trillions of operation every second is very heavy on the hardware. And you can see it in the cost of hardware, in the cost of operation, and the electrical bills and the cooling it needs.
Mm-hmm.
It's simply because when you want to transfer trillions of electrons every second through wires, they heat up and they cannot move as fast as photons. So 11 years ago, I asked myself, okay, we have very nice optical communication, high speed, very low power, especially the fibers, because they are really, really efficient in transferring photons.
Mm-hmm.
So what if we can replace the electronics with fiber-based photonic computing? That means to take a fiber, which is a piece of glass, elongated glass, and somehow to turn it from something that carries photons from point A to point B to something that processes the data when the photons pass through it. And that's the basic idea.
So, if I understand correctly, a big part of it is adapting the photonic technology from just being a data transfer layer to also being to having a compute capability, right?
Yeah, yes. I mean, we can look at the basic example. If we want to implement, let's say, a gate, an electronic gate, a simple AND gate, OR gate, or if we want to implement a neuron, like in artificial neural networks. So if we can do it in photonics, it would be very fast. It could reach, let's say, 100 gig, today 200 gig, 400 gig. And on the other hand, it wouldn't take a lot of power. It wouldn't heat up as much. So that seems like a win-win situation.
Mm-hmm. And
Yeah.
so tell me a little bit about where we're at in terms of productization, and with just for that, so that we have a good basis for the market landscaping. So where are we at today with this technology, with companies building on top of the promise of photonic computing, and what timelines are we talking about?
So we have today in the world about 2 or 3 main technologies of photonic computing. The first family is based on silicon chips. and they are called silicon photonics or photonic integrated circuits. And that's adding additional layers on top of silicon chips so they can become waveguides to guide light. And most of the companies today use these technologies. The main issue is the packaging of the processors and scalability. So if we want to implement, for example, a ChatGPT or other generative AI models, we need hundreds of billions of processors, or let's say parameters.
Mm-hmm.
And the downside with photons is their wavelength. Their wavelength is much longer than electrons. That means that every component is much larger. So let's say 10 by 10 microns, for example, as compared to a transistor of several hundreds of nanometers. So that's about one to 100 ratio. Could be 1 to 1,000 ratio. So things are bigger, but they're much faster and lower on energy. On the other hand, when we look at fibers, the issue of packaging is similar, but the scalability is much easier because we can just connect fibers to fibers. In regular connection, you can find the millions of them in data centers. So we can actually physically build very large network of processors.
So is this the world that we're heading into? That data centers and the data computation layer within our hardware eventually will be fiber and photons instead of what we have today?
So I think eventually, if we look 50 years ahead, we'll have three types of computing machines. We'll have the quantum machines for specific problems, which are, let's say, very hard, very complex. We'll have the photonic machines, which can do, let's say, trillions of full operations every second. That means accelerate about 1 million times from today. Let's say, instead of millions of inferences per second, we'll go to billions and trillions of inference per second. And of course, we'll still have the electronics for control, for training, for a lot of things which are more convenient to make sale. Eventually, we might go to fully photonics, but it will take a lot of time. Okay, so that's the vision.
So yeah, tell me
Just
about
to give an example,
yeah, go ahead.
one photonic machine, let's say in 10 years ago, 10 years ahead, 10 years ahead, sorry, will replace half of the data center today. Okay, that's the ratio of computing capabilities.
Wow. Okay. So Eyal, tell me a little bit about
Yeah,
tell me about CogniFiber. So so now you're an entrepreneur in the space. Tell me about the
yeah.
company you founded, how the journey so far, and really what is it that you're bringing to be part of the larger vision of photonics in the world?
Yeah. So CogniFiber is about a very unique connection between the world of optics and photonics, represented by our CTO, Professor Zev Zalewski, which is a world-renowned photonic researcher, and myself, coming from both hardware, but also the brain research, as my PhD was in neuroscience. And I'm lecturing about the brain for 20 years now. So this combination of hardware, brain, neuroscience, and optics is, is something which is unique to CogniFiber. And we use this advantage. So we look at the brain, we look for how the brain does it efficiently. How does it compute? I mean, what's the difference between regular computers and servers and the brain? Of course, we are not alone. The field of neuromorphics is a very wide field dealing with that. But I think that tapping into the knowledge that I gathered about the brain for the last 20 years with the knowledge in photonics Zev and I bring, that is the major advantage. And they're also the source of differentiators of the company. So, for example, our vision for inference systems is systems where the data streams in from regular fibers in the data centers and streams through the system and does the inference without any reading or writing to memory. That is a unique, let's say, strategy which gives us a very strong advantage in latency and throughput.
And what? How does the product then come to market? What is the product that you're building for the layman?
So we start with small networks and will grow gradually. So we look at the next year, we'll have machine learning systems which are very, very fast, especially low latency. They could go for the market, for example, high frequency trading, where
Mm-hmm.
they every microsecond counts, or they go to data center switching to make the training of AI generative models much more efficient.
Is the play here to work with the larger hardware companies to bring this to market as part of their hardware, or what is the play to market here?
Yes, first we want to show the world that this actually works and works well. So the first POCs will probably without a large partners, and then we can get the traction. Yes, we are in contact with Intel, with Samsung, with NVIDIA, and some of them are really waiting to see how our first products work. They
Mm-hmm.
understand the value. Yeah. So it's about the next 2 years.
Yeah. When you show the product and you try to express the value, what are the key metrics that you care about? Is it mainly the latency and the efficiency of the computation?
Yeah. If we look at the first product, the simple ones, it's mostly about real-time pattern recognition. And we talk about, let's say, 2 up to 10 nanoseconds delay.
Mm-hmm.
That's something which does not exist today. If we talk about future systems, which are larger, we're talking about, let's say, the total cost of ownership of a query for, let's say, generative AI. But also latency, because the customers do want very short latency.
Mm-hmm.
Yeah. So, and people talk about throughput and how to divide the, let's say, the bandwidth, possible bandwidth between customers, etc. So speed is of the essence. And but if you look also, there are some fields that cannot exist today. So we are enablers. For example, smart city. So today, if a smart city wants to connect 100,000 cameras, they need a data center.
That's right.
Okay. and they cannot afford a data center. Most cities. And if we can provide them a system, let's say 30, $40 million, does most of the work. Let's say only a small room with several other pods. That would be enough. So then you can have a smart city. I mean, and the electrical bill will be, about 20 kilowatt, 50 kilowatt, and not 20 megawatt. That's a basic revolution.
Amazing. Wow. So Eyal, what's coming up in the next couple months for CogniFiber?
We are very excited because we are going to present our first prototype, and it's actually MVP. And with this presentation, somewhere along the next Q1 2025, we are going to present this technology. The aim is at least 1 giga inference per second, and with power consumption of up to 100 watts. And that's like, saying we are here. There's a new technology in, rising up, and you better not miss it.
Absolutely. Eyal, thank you so much for coming and for sharing your journey. Sounds like we're in it for the long haul, and especially it sounds like this is a very foundational and very fundamental technology that will change how we experience a lot of different existing use cases, new use cases, and of course we're all getting less and less patient every day. So considering the impact of latency and the speed, I think that's really the key here. So, Eyal, thank you again, and best of luck with CogniFiber. Thank you.
Thank you too, Michael. Thank you for the time.
Thank you so much.